utility locating. Would you please guide me more on how I can use GPR for this case? That's really not what I was talking about at all today. You're talking about seeing the soil layers. So GPR can certainly do that as long as there's enough contrast between the soil layers. A lot of it comes down to if you have different water content than other layers, that's when you're going to be able to see them very clearly with GPR. Based on the properties of the soil. You can, but overall, because the velocity will probably vary between the soil layers, but often the bottom reflector, the deepest layer, then what you may want to do is just use an average velocity of all the material above. Okay. How can I find the exact value of the velocity for each soil layer? Not easy. You can do a type of survey called a CMP, or a common midpoint survey, and you might be able to extract velocity. Hyperbolas that are in the data can help you if you do the curve fitting and extract the velocity, but generally it's not an easy task. As in the case of wet, but reflection coefficient is more. This is kind of ambiguous. The point, a lot of people say that water is electrically conductive. Water is not electrically conductive. Water does not limit penetration of GPR signals. At least it has very low electrical conductivity. When you add salts and other dissolved ions into water, that's when the conductivity increases. So if you have soil that already has salts and this sort of thing in it, and it rains, then yes, the rain is contributing to the conductivity by the fact that it's putting the salts into solution, and then the overall electrical conductivity is being driven up. So when you're in that situation, yes, water can be not a great situation, or adding water to it may not help. But I would also argue that it is very rare to have extremely dry soil. If you dig down a foot almost anywhere in the world, you're going to find moisture. And having it dry, I don't think is typical at all. Typical at all. There's always going to be water in the soil. And so most of the situations that we're collecting data in with GPR, even if it's bone dry on the surface, there is some moisture in the subsurface. So a lot of the times we are collecting in that wet situation. Yeah, I don't think the poll worked out. Somebody asked about the poll question. Fill the empty pipe with water. Well, think about the situation. So basically, we're going from an empty pipe, which would be air filled or gas filled, would have dielectric permittivity of 1. And if you add water to it, then it goes to 80. And so the contrast is going to change. And so again, if you look back earlier what I was talking about, or hopefully review this webinar later, you're going to see that the bigger the contrast, the better it is for bouncing energy off of that pipe. Okay. People telling me how they've been trained. A lot of people used it in the field, on-the-job training. Somebody who came and trained with us on the job, no GPR training. This is what I think is typical. This is a lot of people don't know these little tidbits of knowledge that